Hi everyone, this is Carol. This is lecture problem differential approach problem 2. And what we want to do is run this problem. You'll notice that this is the one we've just solved in the lecture. And we've got 3 resistors, 2 supplies, and then the 6 millihenry inductor. And at time less than 0, the switch is in place. At time t equals 0, it will open up, and we'll be able to do that in our simulation. So let me start. This is every circuit, of course, and what I've got highlighted here are different colors which correspond to the basically the oscilloscope type review above. So you'll be able to see the currents change as we make the transition through the switch modification or the switch opening. All right, so here we go. All right, so as we solved in the problem, after the transition period, which is, by the way, the tau equals L over R is 5 microseconds. So I've set our time at 5 microseconds so that we can see how things do change in the circuit on that time scale. Also, this gives you an appreciation for timing. This is the legend across our page. It's about 20 microseconds. It is 20 microseconds in this length. All right, so at this point in time what we have is, let's look at the red. So we've got, this is at 2 milliamps. Then coming through the 2K, we've got 6 milliamps, and then this is 4K going in this direction, or 4 milliamps going through the 6 millihenry inductor. And the 6 millihenry inductor, as we know, once DC becomes steady state, it basically looks like an open circuit. So that's why there's no current going through the 2K resistor over here. So that's at 0. Now what we want to do is create the transient. So we're going to open this up, and you can see the transient, and this process will damp out after 5 tau, or about 25 milliseconds. So let me stop this so that we can just look and see what happened. All right, so here what we've got is that the current through here, through the blue current, went to 0, and that is as we expect because we've opened up the switch. The current through the 2K resistor, again, because we've gone to time t much greater than 0, greater than 5 tau, we have got 0 amps coming through here. What's coming through here now is minus 2 milliamps, and minus 2 milliamps means it's going in this direction. So we have current flowing in this direction, and you'll see that when I start the symbol. The scale is just changed on our oscilloscope, and we've got 2 milliamps coming through here as well. If we wanted to see what the voltage is up there, I can turn that on, and it turns out that the voltage goes through a little bit of a transient as we set there, but it is basically sitting at 0 volts up here. So that's this yellow line with some transients in it, do the way the simulator works. All right, that's it. Thanks.